Jain everyone. I am Shruti Jain, Assistant Professor, MCA Department from Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to give a small presentation, a detailed discussion on software testing topic. This topic is covered in software engineering subject. The subject code is KCA 302 and this is for MCA students of semester 3. So in the previous presentations, we have discussed about how to develop a software, the different designs to develop a software. Once the software is designed and coded, the software is ready, then it moves into the testing phase. Now this testing phase is an important part of the software development model because this helps in identifying the bugs, the errors in the software and helps in debugging them, rectifying those errors, so that at the end we are having a qualitative software, and when it is given to the user is satisfied and they get the required output from the inputs that they are giving. So if we are talking about the definition of software testing, it is a process of testing the software product. It provides a framework or the set of activities that are essential for the success of the project. They may include planning, designing of the test cases, execution of the program with test cases, interpretation of the outcome, and finally collecting and managing the data. So it again has different steps. So it starts with the planning and designing of the test cases. Test cases are the different cases in which we decide what input do we have to give in order to get the required output. So are we getting those output for a particular input that we are giving? Then we execute those test cases on the program to get the output. And once the output is received, then it is being interpreted whether it is correct or it needs some modification. If it needs a modification, that means the program needs a modification. And finally, collection and management of data. Then the data is collected and managed so that it can be further used. So testing is a process of executing a program with the intent of finding the errors. We basically test the program in order to identify whether there is any error that exists in the whole of the program or the code that we have developed. Effective software testing will contribute to the delivery of high quality software products, more satisfied customers, lower maintenance cost, more accurate and reliable results. Hence, software testing is necessary and important activity of the software development process. Now, the question arises, why should we test the software? First of all, because if we are talking about developing a software, coding the software, everything is a very costly phase. Then adding a new phase, that is the testing phase, is again a costly activity. But yes, we agree that testing the software is costly but at one point of time. But if the software is not tested and delivered to the customer, then if at that time there are multiple bugs coming up, then the cost of rectifying those errors after the delivery of the project would be more as compared to testing the software before delivering it to the customer. So although software testing is itself an expensive activity, yet launching the software without testing may lead to cost potentially much higher than that of testing, especially in the systems where human safety is involved. So in the software life cycle, the earlier the errors are discovered and removed, the lower is the cost of their removal. Now the next question that arises is, who should do the testing? So if we talk about the small projects wherein the team members are very small or it is very limited, the team is limited, in that case we can have the development team and the testing team as the same members, containing the same members. But if we have a very large project, then the development team, the team of developers who develop the code, who write the code, are different from the testing people. So there are different teams for testers, different teams for developers, and for multiple other phases. So testing requires the developers to find the errors in this software. Many organizations have made a distinction between the development and the testing phases by making different people responsible for each phase. So it completely depends upon the size of the project. If the size of the project is very big, then the development team and the testing team could be different. But if it is a very small project with a very limited number of members, then the developers and the testers could be the same people. The next one that we have is what should we test actually. So, we basically test the code by giving certain inputs. We give the inputs and we check whether are we getting the required output or not. So, we should test the program responses to every possible input that is possible. It means we should test for all the valid and invalid inputs. Now, giving the input doesn't mean that you always give the valid input so that you get a valid output. It could be a possibility that you give an invalid input so that the output is again an invalid one. For example, if we are checking for the login authentication, now in that case, if the username requires the 12 characters with a combination of capitals, capital letters, small letters, digits, special characters and all. So, the valid inputs would be giving 12 characters, that is a mixture of all of them. Invalid inputs would be maybe decreasing the number of characters or maybe missing either one or two from the set of characters that is the required thing. So, we should test the project not only on the valid inputs but also on the invalid inputs as well. A program path can be traced through the code from start of the program to the program termination. Now, for that we draw different graphs. Then we say that two paths differ if the program execute a different statement in each or execute the same statement but in different order. So, that could be a possibility when we are executing a conditional statement. So, if the condition is true, then a fixed path will be executed, and if the condition is false, a different path will be executed, but the code remains the same for both of them. The next that we have is a test case, test suite and test data. Test cases are basically a triplet wherein we give the input, we have a state under which that input will be executed, and then we get an output. That is what we are expecting. So, if we are getting the expected output, we say that the test case has passed, and if we are not getting the expected output, we say that the test case has failed and there is a bug in between the code. So, we test that again or we debug that code. Test suite is a collection of all the test cases with which a given software product is to be tested. So, what all test cases we have defined in the previous case, all those test cases when combined together make a test suite. Test data is the input that we are giving to the system in a particular state where the system is to get the expected output. Then we have three different levels of testing: unit testing, integration testing and system testing. Coming to unit testing is basically testing a particular unit, because every software is divided into different units or maybe modules. So, we take a single module at a time, test that module with some inputs to get the expected output, and that is known as the unit testing. We do the unit testing in order to identify the errors, because identifying the errors in a single module is comparatively easy than finding the errors in whole of the code altogether. Now, there are certain conditions or there are certain reasons to support the unit testing. The first is the size of a single module is small enough that we can locate an error fairly easily. It should not be the case that sometimes what happens, the modules itself are very large. There we don't recommend going for unit testing. We take the unit testing only for those modules which are small enough, and detecting the error and rectifying that error is easy. The module is small enough that we can attempt to test it in some demonstrably exhaustive fashion. That means we have different techniques wherein we identify a module and then test it with a particular input. So, unit testing is undertaken after a module has been coded and successfully reviewed. So, unit testing or it is also known as module testing is a testing of different units in isolation. We take a unit, we try to test it with some inputs, and then we identify whether we are getting the required output or not. So, while we are doing the unit testing, because the unit is basically a particular module, but if we look practically, the whole of the software is divided into different modules, and all the modules are interrelated with each other in one way or the other way. So in the unit testing, whenever we are conducting the modules that are under test, these are the modules that we are actually doing. So here the unit testing process is basically going on. While we are conducting the unit testing, it might be a possibility that it would be accessing some of the global data. So whenever it is accessing some of the global data that is stored at some other place, what we do, we give it access to the driver modules. These driver modules contain all the global data that is being required by the module that we are testing in unit testing. But sometimes what happens again, we need to have some of the data from the sub modules through which this module is interconnected. So though the required data that we need from the sub modules, what we do, we collect all those data into the stub module and we make it accessible to the module that we are testing. So module under test is also given two of the things. The first one is a driver module, that is a global data that is being used by this module to access the data or to do the execution. It also is provided with the stub module, wherein the data that we require for again this unit testing to be performed, that data is provided by the stub module. So if we understand the definition of a stub or the working of the stub, a stub acts as a small piece of code that replaces another component during the testing. One of the key benefits of using stub is their ability to consistently return the results, which simplifies the test writing. The next we have is the integration testing. So we have seen that unit testing is testing a single module with some inputs and getting the desired output. But once the unit testing is done, we move to then another level, that is integration testing. Integration testing is when we have 2 or 3 modules joined together. We try to test the interface between those modules, whether it is working correctly or not. So the purpose of unit testing is to determine that each independent module is correctly implemented. This gives little chance to determine that the interface between the modules is correct. And for this reason, integration testing must be performed. So integration testing, it focuses on interaction of modules in the subsystem. Unit tested modules combined together form the subsystems. So while we are doing the integration testing, we have the 2 types of approaches for conducting the integration testing. The first approach that we have is a top-down testing approach. The other one is a bottom-up approach. So coming to the top-down approach, what we have is we try to perform the integration testing at level 1, and we perform the integration testing at level 1 over here, and this level 1 is supplied with the level 2 stubs so that this testing can be performed at level 1. Once the testing at level 1 is performed, then we try to perform the integration testing at level 2. While we are performing the testing at level 2 over here, in that case, the level 3 stubs are provided to these level 2 stubs, these level 2 modules, so that whatever data is being required from this level 3 is being provided to the level 2. Similarly, while the process moves on, then at level 3, the level 4 stubs will be providing the data to make the level 3 integration testing possible. The next approach that we have is the bottom-up approach, which starts from the bottom, that is, we start with performing the testing at the level n, that is the last level. Once the level n testing is being done, then we move on to the previous level of it, that is at level n-1, which is added with some of the test drivers, that is the global data that we need in order to make this integration testing possible. Once the testing is done at level n-1, then we move on to the testing at level n-2 and so on. But Performing the integration testing only using the top-down approach or by only using the bottom-up approach is not possible. Most of the integration testing involves a combination of both these strategies, that is the top-down and the bottom-up approach. The next testing that we have is system testing, wherein we consider the whole of the code as a system. The whole of the software is tested as a whole. Once this is done, we do it in three types of tests. The first one is the functionality testing, performance testing, and the security and the portability testing. While we perform the functionality testing, we try to focus on the functionalities of the software against the requirements that are coded in the SRS, that are documented in the SRS. The performance testing, it checks how efficient the software is, whether it is effective, and whatever load you are giving, is it responding in the stipulated time or not. If it is not responding, then again, we try to identify the bug and debug the code, and if it is working fine, then we proceed ahead. The next testing that we have is security and portability testing. These tests are done in order to check whether the software is, portability means whether the software is able to work on different platforms for which it was being designed, and when the a large number of people are accessing that software, then the security checks are being done or not, the validations are being done properly or not, whether it is authenticating the user to proceed further or is it not authenticating the user to proceed. Next comes the attributes of the software to be tested during the system testing. The first attribute that we have is the usable, that checks whether the product is convenient, clear or predictable. The next attribute that we have is secure, which checks whether the sensitive data is restricted with authorization. Compatible, it checks whether the product works correctly with the existing data, software and procedures. Dependable, in case any failure happens, then are there methods of recovery of the data? Documented, are all the manuals complete, correct and understandable for future use? The next type of testing that we have is acceptance testing. Now, acceptance testing is basically done for those softwares which are designed for the particular customers. In that case, when we are performing the acceptance testing, this testing is done both at the developers, end and the customer's end. When the testing is being done at the customer's end, that is known as beta testing, and when the developers themselves test the code, that is known as the alpha testing. Now, when the test cases are being decided, these tests are conducted by the end users. Those tests, the inputs could be taken ad hoc or any random inputs could be taken, or it could be in a well-planned manner that these are the test cases for which the testing needs to be done. So, the term acceptance testing is used when the software is developed for specific customers. Here, a series of tests are conducted to enable the customer to validate all the requirements. Coming to alpha testing, a team of developers themselves perform the alpha testing by using the system as if it is being used in the work environment. So, the testing that the developers do is known as the alpha testing. They try to find out how the users would react to some of the actions in the software. Beta testing, once the software is tested internally, it is handed over to the customers for their testing, and then the software is actually tested in the work environment. Developers expect that users at this stage will bring minute problems which were skipped to while they were conducting the alpha testing. The next type of testing is a regression testing. Now, this regression testing is a type of a software testing wherein we have made some modification in the software and then we are checking whether that modification is affecting the rest of the software or not. If it is affecting, then what all areas are there, and if whether those areas are changed or modified as per the changed code. So, regression testing is defined as a type of a software testing to confirm that a recent program or code change has not adversely affected the existing features. So in that case, what we do, we have some of the criteria in order to identify the regression test cases. The first one is it requires the knowledge about a system and how is it affected by the existing functionalities. Tests are selected based on the areas of frequent defects where we feel that the test cases are selected to include the area which has undergone a code change many times. So because there the possibility of getting the errors is much high. Tests are selected based on the criticality of the features, how critical the features are which are being implemented now. So coming to the process of regression testing, we have it divided into three main phases. First is the identification of the bugs, modification of the code, and then selection and execution of the test cases. Now, if we look into the identification of bugs, at the first time when the program was executed, there was a program failure due to some bugs. So, we identified that program failure and we debugged the code. Once the process of debugging starts, in that process of debugging, we identified the bugs that caused this program failure. Once these bugs are identified, we modified the source code so that it is bug-free. That means we debugged the program over here. We debugged the source code. Once the debugging process happened, then we move on to selecting and executing of the test cases. We again retest it. So we select the existing test cases which covers the modified and the affected parts of the code that have been changed over here. And on that basis, we generate the new test cases if there is a requirement, or we can proceed with the older test cases itself. Once that is done, we execute those test cases to perform the regression testing. And again, if the program failure happens, the whole process proceeds. Otherwise, we move out of the testing phase, regression testing mode. So there are certain techniques to identify or to select the different test cases for regression testing. The first one is we can select all the test cases that are already available, or we can select some of the test cases randomly. We can pick few of the test cases and from a particular class, and we feel that if one of the test cases is executed properly, then it would suffice the purpose of using the rest of the test cases that are similar to it. Or we can select the modification traversing test cases. We can only select all those test cases which affect the modification part where the source code has been modified, so that instead of testing the whole of the code again, we can only test at what all places this modified code has made an effect. Select higher priority test cases. We can even prioritize the test cases as per their usage or as per their effectiveness, and we can start from higher priority test cases and then we can proceed to the lower level of test cases. So test cases with highest priority has highest rank. For example, test case with priority code 2 is less important than the test case with the priority code 1. So when we are performing the prioritization, in that case, it is being prioritized on the basis of the technical requirements or on the basis of the customer's requirement. So when we are making it, prioritizing it on the basis of technical requirements, the first priority is given to the essential test cases. Then we move on to the important test cases. Then if the resources permit, we perform this level of priority code 3. Then we have the not important or the redundant test cases. Here, we start from here, and as per the time availability or the resource availability, we try to execute the test cases. Coming to the customer requirements, we start with the first priority code, which is important for the customer. Once all those test cases are done, then we proceed to the next one, which improves the customer satisfaction. That could include addition of maybe some functionalities. And last one, help to increase the market share of the product. The next, we have the two types of approaches of testing. The first one is black box testing and the other one is white box testing. When we are talking about the black box testing, in black box testing, the test cases are designed considering only the functional specification of the software. Here, the major emphasis on giving the output and giving the input and getting the output. In this case, while we are performing the black box testing, whatever is happening into the system is not taken care of. Only the input is given and the output is taken up. So, in the black box testing approach, test cases are designed using only the functional specification of the software, that is without any knowledge of the internal structure of the software. In black box testing, the testers only knows the inputs that are being given to the system and what the output the system should give. So, the internal working of the system is not taken care of in black box testing. It involves only observation of the output for certain input values. There is no attempt to analyze the code which produces the output. An approach to testing where the program is considered as a black box because the internal structure of the code is to be ignored. So, if we look into the black box testing over here, we have an input domain wherein we are giving the test data, all the test data that is given to the system. Then we have the system under test, which we totally ignore. We are only concerned about the input domain and the output domain. This is not considered while we are performing the black box testing. So, input test data is given to the system and at the end we get the output test data. So, in black box testing, only these two domains are taken care of without taking care of the system or the functionality of the system. So, in black box testing, test cases are designed from the examination of input-output values only and no knowledge of design or code is required. The last one that we have is a white box testing. It is a complementary approach to functional testing. Here, we try to examine the internal structure of the program. So, if we look over here in the previous slide, where we have taken up the input data and the output test data. So, this was a part of black box testing. But when we are examining the internal system as well, then it is known as the white box testing. So, white box testing basically talks about the analysis of the internal working of the system as well. So, it permits us to examine the internal structure of the program. In the white box testing approach, designing test cases requires a thorough knowledge of the internal structure of the software and therefore, the white box testing is called the structural testing. So, if we look on the overall testing part, we would see that when we are conducting the black box testing only checks about the input and the output. But because the internal working of the system also needs to be checked, in that case, we perform the white box testing. Hence, every software needs to go through both from the black box and the white box testing. Thank you.